Hey, algebra students, Mr. Lawrence here. This is the second of the winter break videos. For those of you doing the work regarding the test and want a chance to earn some points back. Now this one, section 2, I'll send it to you when you send me your results for number 1. So if you haven't got the problems yet, it's because you didn't tell me how you did, or maybe you haven't asked for help, okay? Deadline is Tuesday, December 23rd, so you need to be getting those to me. All right, this type of factoring is just like the last type, only there's going to be 2 types put together. In each problem, there's going to be a GCF. You're going to factor out the GCF, but then what's left on the inside, you'll have to factor further. So let's get down to this. Number 1. Remember, we always look for a GCF first. Now, 2 things about that. It doesn't mean there is a GCF. Okay, the GCF might be 1, which doesn't do us any good. 2, if there's no GCF, it doesn't mean you quit. The problems you did last time didn't have a GCF, many of them. In fact, I don't know if any of them did, I don't remember. But certainly there was factoring to be able to do. There's the ABC method, which works all the time. Gets a little hard when the numbers get a little bit big. There's also the difference of perfect squares and the perfect square trinomial methods. So make sure you're trying all the different types of factoring. I'm going to go looking for a GCF on this black problem here. Looks like it's going to be a 3x because the greatest, well, 3 only has 2 factors, right? 1 and 3. Okay. Does 3 go into 6? It sure does. Does 3 go into 24? Yep. So 3 is a GCF. And this is x cubed, which is x times x times x. So it has 3 factors of x. This one has x times x. It has 2 factors of x, and this one has an x. There's 1 factor in x. So the greatest number of x's that they all have in common is 1. So my GCF is 3x. So I'm going to divide each term in the trinomial by 3x. Now that 3x gets pulled out front, it does not get thrown away. 24 divided by 3 is 8. X cubed divided by x is x squared. 6 divided by 3 is 2. X squared divided by x is x. And 3x divided by 3x is 1. And there you go. Okay, now we're not done. There's 2 more things we have to do. 1, we have to factor inside this quantity, and then 2, because it's equal 0, we have to actually solve it. Okay, now maybe you're not seeing how to factor this right off the bat. That's fine. I'm going to go A, B, C, A, B, C. Easy as 8, 2, negative 1. So 8 times C is 8. Now, I know I'm going to be subtracting my 2 factors of 8 because C is negative. I need 2 factors of 8 that subtract to get positive 2. Well, how about 2 and 4? Now you have to ask yourself, is it going to be 2x minus 4 because we're subtracting, or is it 4x minus 2x? And you need to be careful. A lot of you make a mistake here. You always want to get B. These do not give the same answer. The top one gives a negative 2x as an answer, and the bottom one gets a positive 2x as an answer. Take a look at B. It's a positive 2x. So I want the bottom one, 4x minus 2x. So I'm going to rewrite this. Got my 3x out front. And now I'm going to write 8x squared. Instead of writing a positive 2x, I'm going to write a plus 4x minus 2x minus 1. Now I can group inside that quantity, and really I can change those to the brackets if I want, but I'm going to group here. I'm going to group here, and I'm going to put a plus in between. Now I'm going to GCF each group inside the problem. I'm going to get 3x. Okay. Here it looks like 4x is my GCF. What'll be left? How about a 2x plus a 1? Here I'm not seeing a GCF. other than the fact that they're both negative. I'm going to take out a negative 1. I'll be left with a 2x plus 1, which is good because you notice I wrote down 2x plus 1 twice. Now I'm starting to run out of room, so I'm going to jump over here and then I'll just erase it. So I still don't have my Smart Notebook working, so I can't fix that. I can't just go to a new page or scroll down. All right, got my 3x out front. Now, the GCF here looks like it's this quantity, 2x plus 1. And then I'm left with a 4x and a minus 1, or a negative 1. Now that it equals 0, I have to write 3 equations. I'm going to write 3x equals 0. I'm going to solve for x. I'm going to write 2x plus 1 equals 0. I'm going to solve for x. And then I'm going to write 4x minus 1 equals 0 and solve for x. So solving each of these, x is going to be 0. Taking away 1, 2x is going to equal negative 1. Divide by 2, divide by 2. X is going to equal negative 1/2. I'm going to add 1, going to add 1. Going to get 4x equals 1. Divide by 4. X will equal 1/4. So my solution set would be negative 1/2, 0, and 1/4. And there you go. Okay, so yeah, the problem takes a little longer. Why? Because there's more than one type of factoring going on. All right, let me get the second problem set up here. I apologize that it's taking long, but I'm doing the best I can with what I have. I have been in communication with the tech guys, and they're trying to help me out. So, all right, there we go. So let me move this problem over since I know they're taking so much space up. Uh-oh. I'll just rewrite it over here. Okay. Again, I'm going to GCF. Always looking at GCF first. Now this one's not so obvious. I'm going to take the factors of 45. I'm going to list 1 and 45. 2's not going into 45. 3's going in 15 times. And you are allowed to use a calculator to help you do this. 4 won't go in because 4 goes into 40. And 5 is not a multiple of 4 away from 40. For example, 4 goes into 40 10 times, right? 4 must go into 44 11 times. 4 goes into 48 12 times. Notice I skipped over 45. Okay, 5's going in 9 times. 6 is not going in because 2 doesn't go in. 7's not going in. And 8's not going in. So there's my factors. Now I'm going to start with the highest ones. I'm going to see, does 45 go into 125? And it's okay to use my calculator to check. No, it does not. Does 15 go into 125 evenly? No, it does not. Does 9 go into 125 evenly? Nope, it doesn't. And then does 5 go in? Yes, it does. My GCF is 5. So I'm going to factor out of 5. 5's coming out front. I'll be left with a 9x squared minus 25. Now, we have more factoring to do inside the quantity. Now, this one can be done very easily by doing the difference of perfect squares. You notice that's a perfect square, that's a perfect square, it's being subtracted. It's really easy. If I'll just write off this side here, 3x plus 5. And a 3x minus 5. Oops. Minus 5 like that. Equals 0. Gonna solve. Okay. Now most of you, or some of you, won't be able to do that. So I'm going to go the ABC method because the ABC method works. All right. So A is going to be 9. B is 0 because there is no x term. Right. And C is negative 25. Now if I multiply 9 times 25, I think I get 225, right? And I've got to subtract. But I've got to subtract to get 0. Think about it. Give me a subtraction problem that equals 0. How about 7 minus 7? How about 10 minus 10? Yeah. Did you notice that I had to subtract the same number from itself? So this becomes a very easy problem because 225 must be a perfect square because I have to be able to use the same number to times or minus itself. So I just take the square root of 225 and it's going to be 15. So 15 times 15 is 225 and I need to subtract. So there we go. Now I'm going to rewrite this as 5 times 9x squared plus 15x minus 15x minus 25. All right, gonna group it. And I'm going to GCF in each quantity. So we're going to get 5. And the GCF here, I believe, is going to be 3x. I'm going to pull out a 3x, and I'll be left with a 3x plus 5. Notice the 3x plus 5. Do you notice it showing up? Here I'm going to pull out a negative 5, I believe. And I'll be left with a 3x plus 5. And there you go. Now, I got a GCF inside that quantity. The 5's out front still. Looks like it's going to be a 3x plus 5. And then it'll be a 3x minus 5. And look at that, I got the same exact thing. This one wasn't that hard. I mean, when b is 0, you're going to need the factors of a times c to be the same number. So it's kind of simple. All right, this time I only have to write 2 equations and solve because there's no variable on 5. Some of you are going like this and then crossing it out because 5 doesn't equal 0. I don't have a problem with that. I think that's kind of intelligent on your part. Okay, 3x minus 5 equals 0. And I'm going to solve. Now, I'm not going to take you through the rigors of solving. You can do that. Please make sure that you get a negative 1 2/3 and a positive 1 2/3. Okay? All right, we're going to do 2 more problems here. So let me get my eraser out. I can't even go to the big eraser because I can't get the smart board up. All right, Smart Tech, the notebook. That's what I'm trying to say. Okay, but that's all right. Problem number 3. Problem number 3. You know, if this video is kind of long and boring, I mean, it is long, and you know, it's early in the morning, so I'm kind of tired. I'm not wound up like I normally am. You know, pause it and come back to it later. Watch part of it and take a break. You can do that with any of the videos, really. 54x cubed minus 144x squared plus 96x equals 0. All right, first thing I'm going to do, look for a GCF. Now, I know it's going to be x, but the other part I'm not so sure about. Those are numbers I'm not that familiar with, so I'm going to list the factors of 54 off to the side. 1 and 54, 2 and 27. 3 is definitely going in. Let's see, 3 goes into there. 9 times, I believe, 18. 4 is not going in. 5 is not going in. 6 is going in 9 times. 7 won't go in. 8 won't go in. And now I'm going to check. I'm going to start with one of the numbers, like 96, and I'll see if any of these factors are a factor of it. If I find one, then I'll go to 144 and see if it goes into 144 as well. Now, I'm going to start with the greatest number. I'm not going to start on this end. Some of you will start on this end and you'll say, oh, 2 goes in, but you miss the greatest common factor. Okay, so 54 is not going into 96. 27, nope, not going in. 18, I don't know off the top of my head. I doubt it, but I'll try it. 96 divided by 18, nope, does not go in evenly. Okay, 9, well, 9's not going in. That's an easy one to check because 9 plus 6 is 15, and 9 doesn't go into 15. 6, I don't know, 6 might go in. Let's see here, 96 divided by 6, ooh, 16 times. You know what, I'm going to write that 16 down because I'm probably going to need it. And then 144 divided by 6, 24. Oh, So there it is. My GCF of the coefficients is 6. So I'm going to factor out a 6x. I'm going to divide by 6x, divide by 6x, then divide by 6x. So my 6x is out front. Okay, I'm going to have a 9x squared, I believe, minus 24x. That's why I wrote the 24 there. And plus 16. All right. Now, I have to keep factoring. Inside the quantity is a perfect square trinomial. If I know my perfect square trinomial form, it's going to factor just like this. 3x minus 4 and 3x minus 4. Just like that. Okay? But if you don't recognize it, I'll do it the ABC method. So A, B, C. And that's easy as 9, negative 24, and 16. 9 times 16 is, oh, I know it. 144, yeah, 144. So I'm coming over here with 144. The product is positive, so I'm going to be adding. Okay, now there's a lot of factors here. A lot of factors. Okay, well, I'll go ahead and list them out. 1 and 144, that's ridiculous. They're too far away from each other. Okay, 2 and 72, no, not even closer. Way too far away from each other. 3's going in. I'm not sure how many times. I can figure it out. 48 maybe? 3 times 48. Yeah, 48. Oh, they're still way too far away from each other. Okay, 4 should be going in 36 times. No, too far away. 4 and 36, too far away. I need them to add up to only get 24. So, you know, getting numbers bigger than 24 isn't a good thing. Okay, 5's not going in. I think 6 is going in 24 times. Oh, it's still too big. 7, I honestly don't know. I doubt it, but let's check it. No, 8 should be going in 18 times. Well, this is a start because 8 plus 18 is 26. It's not quite right, but I'm heading the right direction. Okay, 9's going in 16 times, I think. Right? Yeah. And 9, oh, that's 25. Oh, so close. So close. 10's not going in. 11's not going in. Oh, 12. 12 times 12 is 144. Now, if you had seen that right off the bat, you could have gone right to it. You didn't have to do all that work. So I'm going to need a 12x and a 12x. I need to add them, but if I add 12x and 12x, I only get 24x. I want B. I want negative 24x. So I'm going to make them both negative. Can I do that? Sure, because C is positive. Plus in the back is the Wendy's double stack. So we're going to get 6x and then 9x squared minus 12x plus 16. That'll equal 0. Now it's time to group. And so I'll have a 6x, and then I'll divide by 3x, divide by 3x, 3x minus 4. And then here I'm going to factor out a negative 4, I think. Oh, by the way, did you notice the 3x minus 4? Okay, so I'm going to factor out a negative 4. And I'll be left with, sorry about that, I'll be left with a 3x minus a 4. So I hear myself repeating a lot, which means there's a GCF in there. And it'll be 3x minus 4. And I'll be left with a 3x and a minus 4. Now I have to solve. 6x equals 0. 3x minus 4 equals 0. And I'm not going to waste my time writing down the next equation because it'll be the same exact thing. I'll leave it up to you to solve. I'll tell you should get 0 and 1 1/3. Okay, there you go. All right, one last problem and then we'll call this video Okay, now remember, you want to be sending me your results. I'm not sending you the next set of problems until I get results from you. Okay, at the time of recording of this video, there was only one person who sent me results. Oh, excuse me, only 3 people who've sent me results. All right, apologize for that misspeaking there. Okay, last problem. This one's a bit strange. It's x to the 17th minus x equals 0. All right, first thing I'm going to do, GCF. I'm going to pull out an x, and I'm going to get x to the 16th minus x. Nope, minus 1, sorry. Equals 0. Now, in here, I'm going to use the difference of perfect squares. And I see that this is a perfect square with x to the 8th as its square root, and this is a perfect square with 1 as its square root. So it's going to factor like this, x, and then x to the 8th plus 1 times x to the 8th minus 1. But if this one here was a perfect square, or a difference of perfect squares, so is this. X to the 8th is a perfect square. If I take the square root of it, I get x to the 4th. And that's a 1. So this part here is going to break down. This one won't. These are both perfect squares, but there's no subtraction. It's not the difference of perfect squares. All right, so I'm going to get x to the 8th plus 1. And here I'm going to get an x to the 4th plus 1 times the quantity of x to the 4th minus 1. But this is a perfect square minus a perfect square, so it's going to factor even more. X squared, 1. So we're going to get x to the 8th plus 1, x to the 4th plus 1, and then here we'll get an x squared plus 1 and an x squared minus 1. Uh-oh, do you see what I'm seeing? I see another difference of perfect squares. Right here, this is a perfect square minus a perfect square. So the final factoring will be x times x to the 8th plus 1 times x to the 4th plus 1 times x squared plus 1 times x plus 1, all quantities, times x minus 1, and now nothing else can be factored. Now, when I go to solve this, I actually, I'm only going to do 3. I'm going to solve 1, 2, and 3. Because watch what's going to happen when I try to solve x squared plus 1 equals 0. I'm going to subtract 1 from both sides, and I'm going to get x squared equals negative 1. Well, when I go to take the square root, I'm going to be x equals the square root of negative 1. That's an imaginary number. We don't deal with imaginary numbers in this class. So I only have to worry about x equals 0, x plus 1 equals 0, and x minus 1, x minus 1 equals 0, and solve those. These 3 here will produce imaginary numbers. Now, I'm not going to test you on this specifically, that part, but I wanted to get through the point of the multi-tiered factoring. By the way, your solution set will end up being negative 1, 0, and positive 1. Okay? If you were going to try to do this one by the ABC method, it gets a little complicated. I can show you real quick. I'm going to pick it up from this line here. Okay, A is going to equal 1, B is 0, and C is negative 1, right? And so AC is going to be negative 1. And the only factors are 1 minus 1, right? So that's easy. But when you go to rewrite it, you got your x out front. You got an x to the 16th, and you got this minus 1. You can't put x in x. You won't get the GCF you want. You have to actually put x to the 8th minus x to the 8th. And how did I know that? Well, I used the square root of 16 of x to the 16th. So it gets a little bit complicated to do it this way. I don't think I've ever done it this way. I would probably always do the difference of perfect squares. All right. You're welcome to try, though. All right, that's it for the video. Mr. Laurence signing off. Have a good night, everybody. Don't forget to email me with your questions. Bye-bye.